I know you're already familiar with finding eigenvectors, so in this lecture, I won't be teaching you how to find them. Instead, I'll help you understand why they're so important. We know that a matrix represents the transformation of space. In our case, we have a 2 by 2 matrix, so there are 2 eigenvectors associated with it. Now, let's take some random vectors and transform them using our matrix. After the transformation, we get a new set of vectors. Do you notice anything special in those new vectors? No worries if you can't find it. Let me add some color to make it clearer. Do you see it now? Yes, you guessed it right, the green border vector are the special vectors. Focus on the 4th row. The input and transformed vectors are identical. Isn't that cool? This is the vector which did not change after the transformation. In other words, the direction of vector remained same even after transformation. Whereas all other vectors has changed. Yes, you got it right, that's an eigenvector. Great job. But hang on, why is the 2nd row also green? The vector there did change after transformation. The input was vector is 3 and 1 and the transformed vector is 15 and 5. True, the vector changed, but the output is just a scaled version of the input. If we factor out 5, we're left with the original vector 3 and 1. So, its direction is unchanged, just scaled. Once again, you're correct, that's another eigenvector. So, we've found 2 eigenvectors for our matrix. Here's the key point. Vectors that don't change direction after a transformation are called eigenvectors. Now, what about that scaling factor? It always comes hand in hand with eigenvectors. You guessed it, that number is the eigenvalue. Woo, you just understood eigenvectors and eigenvalues. So, we discovered that the eigenvalues correspond to the eigenvectors are 1 and 5. Wow, you've just grasped eigenvectors and eigenvalues. To recap, vectors that don't change direction after matrix transformations are eigenvectors, and the amount by which they're scaled is called the eigenvalue.